Hi class, today we're going to learn how to convert a quadratic equation from standard form to vertex form. For each quadratic function in standard form, f of x equals ax squared plus bx plus c, complete the square to convert to vertex form, f of x equals a times x minus h squared plus k. Identify the vertex and transformations from the parent graph, and graph 5 key points without making a table. Vertex form is extremely useful because, well, it gives you the vertex, and it also can help you tell what the transformation is to help you graph it a lot easier. So that's what we're going to do today. We're going to convert from standard form to vertex form. When we are converting, there are certain steps that we like to follow. The first step is to isolate the variable terms, just like when we were solving by complete the square. Isolate the variable terms. The variable terms in this case are 3x squared and 24x, so we're going to subtract 41 on both sides. So what we have is f of x minus 41 on the left, and then we have 3x squared plus 24x. Step 2, check if a equals 1. If a doesn't equal 1, then divide both sides by a. In this case, a is equal to 3, so we are going to divide both sides by 3. On the left, we're going to leave it in this form, f of x minus 41 all over 3. But on the right side, if I divide each term by 3, we have x squared plus 8x. Step 3, complete the square by adding b over 2 squared on both sides. So in this case, our b value is 8. So we're going to add 16 on both sides. Plus 16 here, and then why don't we add 16 over here? This is now going to allow us to rewrite as a perfect square. Step 4, rewrite the perfect square as a quantity squared. So on the right side, x plus 8x plus 16 would factor out into x plus 4 times x plus 4. So we have x plus 4 squared, and on the left we still have the same thing. Finally, for step 5, we're just going to solve for f of x. So we're going to look at f of x. We're going to think about everything that's happening to it and undo it. So looking at f of x here, it is subtracted 41, divided by 3, and added 16. Everything I just said, we're going to do it in the opposite order. I'm going to subtract 16 on both sides. So then I have f of x minus 41 all over 3 is equal to x plus 4 squared minus 16. Then we're going to multiply both sides by 3. We know what's going to happen on the left, but on the right, if I'm going to multiply that by 3, we need to recognize that we are multiplying that entire quantity by 3. And when I multiply by 3, it's going to multiply the x plus 4 squared, and it's going to multiply the 16. So what I end up with on the right is 3 times x plus 4 squared minus 48. The last thing we need to do to isolate f of x is to add 41 on both sides. And we have f of x is equal to 3 times quantity x plus 4 squared minus 7. So now that we have our vertex form, we can identify the vertex. The vertex is negative 4, 7. If we wanted to check if our vertex form was correct, we can graph this in our calculator and graph standard form at the same time. If we only see one graph, that means they're the same graph overlapping each other. If we see two different graphs, then that probably means that there was something that we may have made a mistake on to get this form. But let's go ahead, and now that we have vertex form, let's do what it's useful for. Let's graph it. So it has an h value here of -4, an a value of 3, and a k value of -7, and this all helps me describe the transformation. So let's write that down. The function is horizontally translated. Left 4 units, vertically stretched. It's a stretch because the a value is 3, so vertically stretched by a factor of 3, and vertically translated down 7 units. So in order to graph it, I need my vertex, which is at -4, -7. That's going to be right here at this point. It might also help to have my parent graph. My parent graph always has a vertex at 0, 0, points at 1, 1, and 2, 4 that reflect to the other side. And I want to keep in mind the motion that I'm following to graph it, right? So it's from the vertex, I go to the right 1 and up 1 to get to my first point. So I'm going up 1 here. To get to my next point, I go to the right 2 and up 4. So I'm going up 4 here. But for my transformed graph, there's a vertical stretch by a factor of 3. So instead of going up 1 to here, I'm going to go 1 times 3 is 3. So I'm going to go up 3. 1, 2, 3. Instead of going up 4, I'm going to go up 4 times 3. 4 times 3 is 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12, and I end up here. So my key points for my transformed graph are these points, and then I can reflect them over because parabolas are symmetric. And there is my transformed graph.